Good morning, students. I hope you all are fine and you must have covered and revised the previous topics of this chapter. So, by hoping that I am proceeding with the next topic, the first topic of today is effect of temperature and pressure on states of matter. First, effect of the temperature. Number 1, solid changes into liquid and liquid changes into gas by increase in temperatures. Okay. Similarly, third and fourth point, in which gas changes into liquid and liquid changes into solid by decrease in temperature. So you can see in this slide that how the states of matter are convertible due to increase in temperature or decrease in temperature. Next is effect of pressure on solids. There is no effect of pressure on solids because solids are not compressible. We have done in differences question, remember the difference between solid, liquid and gas. So as you know, solids are non-compressible, so as there is no space between the particles, so what will happen if you will apply pressure on solids? They ultimately broken and their shape will be changed. Similarly, liquids, there is no effect of pressure on liquids also because they are also non-compressible, as there is not enough space between the particles. So that's why there is overall no effect of pressure on solid and liquid. But there is a very strong effect of pressure on gases. If you will increase pressure on gas, the volume of gas decreases. If you are taking a cylinder in which gas is there and somehow you are applying pressure on the gas, so what will happen? As you know, the gas particles take the all over space of the container. So when you are applying pressure on it, ultimately those particles will come closer to each other and their volume will decreases, right? So that's why the gases are highly compressible in nature. Due to their compressibility nature, they can be easily transported and they can be easily stored in small cylinders also. You can see in this slide that the gases like liquefied oxygen, which is used as a propellant, as a fuel in spacecraft rockets. So liquefied oxygen is also used for medical reason, industrial reason. How liquefied oxygen is formed? If the oxygen gas is pressurized, it is converted into liquid, and liquefied oxygen is of blue color. Similarly, carbon dioxide gas, if you will apply more and more pressure on carbon dioxide gas, it will directly changes into solid. So solid carbon dioxide is known as dry ice, which is used in the storage of food also, as you can see in this. But if you will decrease the pressure, then liquefied gas turns into gas. Fine. Next topic is unit of temperature. There are three units: degree Celsius, Fahrenheit and Kelvin, but in your syllabus degree Celsius and Kelvin is in detailed, so I will explain it to you. You should remember that 0 degree Celsius is equal to 273 Kelvin. So if you have given any digit in degree Celsius and they are saying convert in Kelvin, you have to plus 273. So to convert Celsius into Kelvin, add 273, but to convert Kelvin into Celsius, you have to subtract 273 from the given digit. And you can see in this slide also that I have mentioned, if you have to convert degree Celsius into Kelvin, add 273. As I have mentioned that 0 degree Celsius is always equal to 273 Kelvin. So if 25 degrees Celsius is given to you, so you have to write 25 plus 273 is equal to 298, and its unit will be converted from degree Celsius to Kelvin. Fine. Similarly, in next example, 56 degrees Celsius is equal to 56 plus 273 is equal to 329 Kelvin. And in next case, as you have to convert Kelvin into Celsius, as it is given 340 Kelvin. So 340 minus 273 is equal to 67 degrees Celsius. So don't forget to change the unit when you are converting from degree Celsius to Kelvin and from Kelvin to degree Celsius, right? So this is all about today's lecture. I hope every topic is clear to you. Go through this slide twice at least, so that every term, everything will be clear to you, and maintain your notebooks and take care.